Okay, the mean value theorem. This is the last slide that I covered in the last lecture. So again, the mean value theorem is what? The mean value theorem is having an interval with an interval, let's say A and B. So this doesn't mean that the function value at A must be equal or it must not be equal to. Okay, so there will be two possibilities, that it will be equal to or it will be not will be equals to. So there's a slight difference between Rolle's theorem and mean value theorem, and Rolle's theorem is a special case of mean value theorem that I described in the previous lecture. So the mean value theorem is, let f be a continuous over a closed interval with values a and b and differentiable at open interval ab, and there is at least one point c which is a member of a and b. So function derivative of c will be equals to f function value of b minus function value of a divided by b minus a. This is mean value theorem. So this is how we find the value of derivative of a point which is c within the interval a and b. Okay. Now verifying the mean value theorem applies. So let us say that for my value, of interval, let us say this is f of x equals to under root x on an interval 0 and 9. So show that the f satisfied the hypothesis of mean value theorem, and therefore there exists at least one value of c within this range O 0 and 9, and the derivative equals to slope of 9 connecting as 0 with derivative and 9 and this one. Okay, so first I have to do this, that the derivative f of x is under root x. So the derivative will be, f derivative will be, as f of x equals to x into 1 upon 2. So it will be f derivative of x will be, just give me 1 second. Okay, f derivative of x will be 1 upon 2 x, 1 upon 2 minus 1 according to power rule. So it will be 1 upon 2 x minus 1 upon 2. So it will be f derivative of x. So it will be 1 upon 2, and then this will be in denominator. And when I put in here, that is denominator. So this value of power must be positive. So it will be 1 upon 2 under root x. This is the value of derivative. Now I have to find the value. This is the derivative. Well, this is step number 1. Step 1. Okay. So for step number 2, step 2 is find the f derivative of c, which will be equals to what? F function of b minus function of a divided by b minus a. And what is the function? Function is under root x, and the values are 0 and 9. Okay, so 0 is a and b is 9. So it is under root, function value is under root 9 minus under root 0. Then the simple value is 9 minus 0. So it will be 9, that is 3 square. So 3 square under root minus 0 divided by 9. So it will be 3 divided by 9, which will be equals to 1 upon 3. This means that my f derivative of c equals to 1 upon 3. Okay, as I find and the derivative of f of x equals to 1 upon 2 under root of x. Okay, so f of c will be what? Just replacing the value x with c. So this one. So this is basically the derivative, f derivative of x. This will be f derivative of c equals to 1 upon 2 under root c, which I find in step number 1. So I have to replace this value here. So this will be, just give me 1 second. So yes, this will be 1 upon 3 equals to 1 upon 2 under root c. Then I have to cross multiply it. So this will be here and this will be here. So 2 under root c equals to 3, and under root c equals to 3 upon 2. Now taking the square on both sides. So c equals to 3 square is 9 and 2 square is 4. So c equals to 9 upon 4. Okay, so at this point, the slope of the tangent line equals to slope of the line joining the endpoint. So this C value basically is the slope of tangent line, is a point where slope of tangent line equals to slope of line joining the endpoints. So this is how we find the value, that is C equals to 9 upon 4, and the value of the function is 3 upon 2 respectively. So this will be this point. And the next point is function value, that is at 9 and 3 respectively. So this is 9 and here it is 3. Okay, so this is how we find, and the function started from 0 0 origin. So this is all about this question. Okay, now mean value theorem and velocity. For rock is dropped from a height 100 feet, its position t second after it is dropped until it hits the ground is given by the function that s of t equals to minus 16 t square plus 10. So determine how long it takes before the rock hits the ground, and find the average velocity, and find the time and instantaneous velocity. Okay. So first started with how long it takes to hit before the rock hits the ground. Okay, my function is minus 16 t square plus 10. So as to find the value for time, so s of t, as s of t equals to minus 16 t square plus 10. So for finding the time, always remember that my distance function equals to 0. So I have to put that 0 equals to minus 16 t square plus 100, and then 16 t square equals to 100, and t square equals to 100 divided by 16. So taking the under root on both sides, so t equals to 10 upon 4. Okay, so it will be 5 and 2, and there must be a positive and negative sign because I'm taking the under root. So t equals to plus minus 5 upon 2 seconds. So this means that the value of t will be plus 5 upon 2 and value of t equals to negative. As we know that the value of time is always positive, so t, my answer is t equals to 5 upon 2 second. So the ball will hit the ground 5 upon 2, that is 2.5 seconds after it is dropped. Okay, so this is the solution of part number 1. For part number 2, I have to find the average velocity. So for velocity, as I know that this is the derivative of the point, derivative. So I know that to find the derivative, I can use my mean value theorem. So mean value theorem depends on the value of s of b minus s of a divided by b minus a. Okay. So what is B and what is A? So B basically is first A and B. A value when the ball is in hand. So at starting the time, this is basically the function of time. At start the time is 0, and when it hits the ground, as I find is 5/2. So at start, my initial time is 0 because it is the starting point for the starting interval. My t value must be equal to 0. And when it hits the ground, my t value is 5/2, which I find in part number 8. Okay, so I can put the value s of b. Now function of b will be that s of 5/2. It will be equals to putting the value here. So it will be negative of 16, 5/2 square plus 100. So it will be negative 16, 25/4 plus 100. And after solving it, the function value at 5/2 equals to 0. So this value at 5/2 is 0. Now I have to find the function value at 0. So s of 0 will be putting the value of t equals to 0 for my function. So it will be s of 0 will be negative 16 of 0 plus 100. So s of 0 will be 100 respectively. So 0 minus 100 divided by what is the value of b? B value is 5/2 minus 0. So it will be negative 100 divided by 5/2. So it will be negative 40 feet per second. This is the value of average velocity. Okay, this is the second part. Now moving towards part number C. Now I have to find the time guaranteed by mean value theorem when the instantaneous value of rock is V average. Okay, so I have to find the time. Okay, the instantaneous value is given by derivative of position function, that is derivative of s of t. Therefore, we need to find the value Vt and s of t, which is basically the average. And I find that this value is negative 40. And it is continuous over A and B point. A point is 0, B point is 5/2, and I differentiate with respect to 0 and 2, and my C value lies between them. Okay, so I have to find S derivative of C for my function. So it will be again S 5/2 minus S of 0 divided by 5/2 minus 0. This is by using, again, I use the mean value theorem. So my answer for this is negative 40. Okay. So by using mean value theorem, my value is negative 40. So taking the derivative of S of t, so I have to take the derivative. So my S of t will be minus 32t as, just give me 1 second. S of t function is what? Minus 16 t square plus 100. So my derivative value will be S derivative of t will be minus 32t. Okay. So for C, it will be S derivative of C will be equals to negative 32C. Okay. So I have to compare both the values. S derivative of C is 32 by 32C, and S derivative of C by using mean value theorem I find is negative 40. So I have to compare both. So it will be negative 32C equals to negative 40. Negative negative will be cancelled out, and C equals to 40 upon 32, which will be equals to 5/4. Okay, so therefore 5/2 seconds after the rock is dropped, the instantaneous value equals to average value. तो यहाँ पे हमने क्या फाइंड किया है, वो टाइम जब मेरी इंस्टेंटेनियस वैल्यू दैट वो वैल्यू जो मेरी वेलोसिटी की है, जो एक स्मॉल टाइम के लिए है, इट मस्ट बी इक्वल्स टू द एवरेज वैल्यू ऑफ द रॉक. सो दैट इज for this the time equals to 5/4 seconds, and the velocity equals to minus 40 feet per second, which I find using mean value theorem. Okay, so this is basically s of t function, which is negative 16 t square, and this one. Okay, so this is 5/2 point for this curve. Okay, for this curve, if this is the curve for this function, and I joined with respect to 5/4 and 5/2 respectively. 5/2 is this one, that is my A and B part. A is basically 0, जो मैंने डिस्क्राइब किया था कि starting my time is 0, और जो B मैंने फर्स्ट टाइम जो फाइंड किया था फर्स्ट में, that is 5/2. So firstly I have to allocate this. This is my point number A and this is point number B respectively. Okay, and this is the फंक्शन, ये मेरे पास फंक्शन की वैल्यू है, फंक्शन की कर्व है. ओके, नाउ दिस वैल्यू इज 5/4. इंस्टेंट तो मैंने एक लाइन ड्रॉ करनी है जो इस ग्राफ को टच करे, दैट कट्स एट दिस पॉइंट. So this will be my point t equals to 5/4. The velocity of rock is equals to average velocity. That is my instantaneous velocity equals to average velocity of the rock drop. So for this is all my points. Now this line basically joining the peak value at this one, and this value is basically make a line with cuts at this point, and this is basically showing the dashed line here. Okay, so this is all about the graph. Okay, now correlates of mean value theorem. So if this is the man, corollary 1, if function be derivative at interval I. Okay, so if derivative of x of f derivative of x equals to 0 for all x is member of I, then f of x equals to constant of all of x derivative of I. So what does this mean? That this means that, let us say my function is differentiable at interval I, where interval I starts from 0 to 100. Okay, then my if f derivative of x equals to 0 for all x is member, that it is 0 for 0 to 100, then f of x equals to constant for all. So this means that this value is constant, that जब मैं पुट करूंगा 0 तो मेरी फंक्शन की वैल्यू 0 आएगी, जब मैं 100 पुट करूंगा तब भी 0 आएगी, जब मैं 50 पुट करूंगा जो कि इसके इंटरवल के दरमियान में है तो फिर भी 0 आएगी. सो दिस मींस दैट f of x is constant for all the values. Okay, so you can explain. Now the quality 2 is if function that is f and g are differentiable at interval I, so f derivative of x and g derivative of x for all the values of the interval, then f of x equals to g of x plus c. Okay, so for this function, when there are two functions, that f of x and g of x, the derivative of x equals to g of x, this means that f of x equals to g of x plus c. Okay, now increasing and decreasing functions. Let us say I have the sine interval. So my if f derivative is greater than 0, so it means that my function is increasing function. And if f derivative of x is less than 0, this means that function is decreasing function. Okay, these are the basic 4 or 3 corollaries for my mean value theorem. First one, I explained again that if the derivative is 0 for all the intervals, that अगर मेरा derivative of x की value सारे इंटरवल के लिए 0 है, तो इसका मतलब है कि जो मेरा एफ ऑफ एक्स है वो क्या है, एक कांस्टेंट वैल्यू है। अब लेट अस से अगर मेरा कांस्टेंट वैल्यू है, तो मैं एग्जांपल देता हूँ इसमें। लेट अस से एफ ऑफ एक्स मेरे पास 100 है, तो इसका क्या मतलब हुआ कि जब भी मैं डेरिवेटिव लूंगा इस पॉइंट का, वो हमेशा 0 ही रहेगा किस मर्जी इंटरवल पे। तो सारे इंटरवल्स पे जब मेरी वैल्यू 0 आ रही है, इसका मतलब है मेरा फंक्शन क्या है, एक कांस्टेंट है। ठीक है। नाउ द नेक्स्ट इज, अगर मेरे पास दो फंक्शन जिनके डेरिवेटिव सेम है, तो इट विल बी इक्वल टू एफ ऑफ एक्स इक्वल्स टू g of x plus c. Okay. And the third one, if it is greater than 0, it is known as decreasing function, and it is less than 0, it is known as decreasing function respectively. So this is the end of the job topic 4.4. We'll meet in the next lecture, inshallah.